So first thing about quadratic function, you have to know that maximum number of x-intercept for a quadratic function is 2. Okay, situation with 0 x-intercept. I'm going to give you this example. You tell me, is my example correct? Sorry, I shouldn't put an A. I should give you a number. Still remember yesterday we said that if I write in this form, okay, you don't have to know this for this stage. Yeah, you just need to know. Okay, so for those who didn't take MX, you find it whatever I say yesterday is difficult. Don't worry about that. You don't have to know the turning point, because later when we have the graphic calculator, you can use your graphic calculator to get the turning point. So you don't have to bother to go and know what is the turning point. Yeah. So just put that aside. So, and you also don't have to know how to sketch the graph, because later when we have the graphic calculator, the graphic calculator will help us to sketch the graph. So don't be frightened by, I know how to sketch the graph, yet you don't know. Do you get me? So sketching graph, the skill of how to sketch the graph manually is not part of what we need to know for 6, because you have the graphic calculator. So put that aside, because skill of sketching graph is a very tedious skill. Okay, so don't let that burden you. When you get your graphic calculator, I will teach you how to use your graphic calculator to sketch. Do you get me? So because yesterday someone told me very difficult. Okay, so I'm going to use this information to sketch the graph. Okay, so the graph will go some sort like this. If you have a graphic calculator, straight away we can. So we know that because the A is 3. Okay, this you know, don't know, doesn't matter. Huh? So I have to make it clear. If not, you all get very frightened. So A, what happened to mine? A is equal to 3, so greater than 0. My graph will go like this, smiling. Okay, smiling curve. You smile. Okay, so the minimum point will be 2, 3. Am I right? So you look at the graph. The graph will go like that. Am I right? So does it cut the x-axis? No. That's why this is a situation without x-intercept. Okay, without x-intercept. So I purposely do this. There's a reason I want to bring in a concept. I can straight away know that whether it is with or without x-intercept by using a term. After I will show it to you. Okay, for B, if you look at here, for B, if you look at here, so this is your A. So your A is equal to -1, which is less than 0. If your bank account is negative, I think you will feel very sad. Am I right? So the graph go in this way. Sad face. Am I right? So you learned this before in your high school. So the maximum point, so there is a maximum point. So the maximum point for this case is half -2. So the maximum value of y is -2. So that means the rest will be less than -2. So the whole graph will be below the x-axis. So it doesn't cut the x-axis. Am I right? So this is your half -2. Am I right? So listen here. For this case, the range means all the possible value for y. So these are the terms that you have to get it right. Huh? The range is all the possible value for y. Domain are all the possible value for x. That is the manipulated variable. For this case, because it's a polynomial, x can take any real value. Are you clear? Okay. Same go with here. The range is, please, you have to know what is range and what is domain. Important. The range for this case is y. Y is a member of real number, all real number, and y is less than or equal to -2. So these are called range, possible value for the dependent variable. Domain, because it's a polynomial, is understood the manipulated variable can take any value as long as it is real. So remember, this symbol R means real value. In maths, all the number that you know so far are real. Is there an unreal value? Is there? Not real, imaginary? Yeah. So I'm going to show you through these examples. Okay. So are you okay so far? So good? So have to know what is range and what is domain. Because later I will introduce with other function whereby you have a different domain, not real value. Clear? Okay. Shall we move on? Okay. So yesterday we said that all quadratic function can be written in a general form. That is y equal to ax squared plus bx plus c. If you have a quadratic in a general form, yeah, if you want to find the x-intercept, okay, that means you have to put it means y coordinate is 0. Am I right? Sorry. Y coordinate is 0. So that means ax squared plus bx plus c equal to 0. You can solve this in 2 different ways. Am I right? Or I can say 3 different ways. One is using your scientific calculator. Do you know how to use your scientific calculator to get the answer for a quadratic function? Okay, your friend knows. So I'm going to use just on my example, that is 3x minus 2 squared plus 3. I'm going to expand it to write it in a general form. Yeah, you give me 1 minute. Just now I have the first function, correct? Y equal to 3x minus 2 squared. May I know plus what?
Plus 3.
Can you? Plus 3, thank you. The person online is more alert than you're in the class. Okay, so if I expand this, so expansion is a must to know as well. Do you know how to expand? Do you know what formula am I using to expand that? Do you know why I can expand so fast? You have to memorize this formula. If you have A plus or minus B squared, the front squared plus or minus 2 times the front and the back plus the back square. Am I right? So please remember that so that you can expand fast. Okay, so when I rewrite this, okay, so I get 3x squared minus 12x plus 15. Am I right? Okay, good. So the one that beside x squared is called your A. So this is your A. So this thing is the B. And this one is your C. Include the sign, huh? Are you clear? Okay, so we know that there is a formula that helps us to find the solution for a quadratic equation. Do you remember the formula? The formula is x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So whether a quadratic function has an x-intercept or not is determined by this one. So we call this the determinant. So as long as we know what is the value of the expression of b squared minus 4ac, then we will be able to know whether there is an x-intercept or not. So let us have a look at this case. So that is a very important fact. Huh? Okay. So let's have a look at A. Let's see. B squared minus 4ac. So you can take out your calculator and calculate b squared minus 4ac. I straight away know that it is less than 0. Am I right? Because 4 times 3 is 12. 12 times 15 definitely is greater than 12 squared. So that is how you think in your mind. You don't need a graphic calculator. You don't need a calculator. So you get negative what? 36. Why I can calculate so fast? In this case, let me show it to you how I operate this in my mind. How many 12 do I have in the first one? I got 12, 12, correct? The second one, I got 15, 12, correct? So if I take off, I still lack of 3, 12. That's how I get negative 36. I'm much faster than the calculator. I'm just telling you, you don't have to know this skill. I'm just telling you that how your mind works. when you talk about calculation, it doesn't mean that there is the only way. It doesn't mean that you have to multiply first, then only you minus. So you can change the rule, depend on the situation. Am I right? Do you see how I read? I got 12, 12. I take away 15, 12. So I lack of 3, 12. So that is how it can improve your algebra. Like I got 12x minus 15x. So I got negative 3x. That is how your mind works. If when you are in a primary school, your teacher teach you how to multiply in that way, then your algebra will not have a problem. Do you get me? So that's why the way we think in our mind, it really determines the way we learn in maths. The rule is multiply first and plus or minus, correct? Followed by the rule. But can I change the rule? Yes, for this situation, I can change the rule because there is a common factor. So you can factorize it. So that's why I tell you, I can teach year 6, year 7 student factorization because I teach them how to calculate in that way. Common factor, very important. Okay, just happened, I come up with a question like that. So I talk about that a little bit. So you see the determinant is less than 0. So I ask you, can you find a square root of negative 36? No. But in maths, I can break this into square root of 36 times square root of negative 1. And in maths, especially those who want to be an engineer, electronic engineering, you have to know that square root of negative 1, it doesn't exist as a real number. It exists as an imaginary number. So we call square root of negative 1 is an imaginary number. So in maths, we have 2 types of number. One is real, it's tangible, touchable, you can see. One is not real, but is helpful in our everyday life, especially for those who are doing electronic engineering later. It makes things work. How is it like that? You have to go and ask the mathematician who invented this. I'm not an engineer, so I can't tell you deep how it applies. Maybe next time you do engineering, you can come and share with me. Yeah. So this got imaginary number. Imaginary number, that means not real. So this is, so 6i. So it's not real. Hello, are you clear? So as long as b squared minus 4ac is less than 0, yes, as long as b squared minus 4ac is less than 0, then what happened? We call it, so better remember, so this determinant is very important. So what you need to remember, you don't have to remember the formula. Okay, if you key this into your scientific calculator, please take out your scientific calculator and learn how to find the roots using your scientific calculator. If you don't know, ask the person beside you. So what is the answer? What is the answer? If you put your x equal to, what is the answer given by your graphic calculator? Yes, 2 plus I. 2 plus I. Plus 2 plus I. Sorry, this is vector already. 2 plus I. And the other one is 2 minus I. So it's not real. Understand? Everyone got that with your scientific calculator? Is there anyone get the different one? No. Okay. Do you know how to get it from your? I told you already. If you don't know, ask your friend beside you. Do you know how to get? Or the one at the back of you? You know how to do? Please, I told you already just now. Those online, you know how to do?
Yep.
So this is one thing that we have to remember. Other thing, all the formula you don't have to remember, is okay. So if b squared minus 4ac is less than 0, then no real root. No real root means no x-intercept. That means, in another word, is no solution. So I'm going to make a conclusion from here. So there are 3 situations. Are you okay so far? Because this is the most important one. Other than that, it's okay. You can use your calculator. That's why I don't want to go in depth to make everyone go crazy. Yeah. Go straight to the important point, correct? Okay. So just now so I'm not going to do the other part of it. The part B, you can do it by yourself if you want. So situation with 0 x-intercept. Okay, let's see situation with 1 x-intercept. How would it be like? Okay, situation with 1 x-intercept. So I go to number 3. I decided to change the way I teach just a few minutes ago. Okay, 3 with only 1 x-intercept. Okay, so I'm going to give you an example. Okay. Now you are allowed to use your scientific calculator to find your x-intercept. So x equal to 3. If you don't want, you can also factorize. You see, it got the same factor. Am I right? If you have a graphic calculator, when you sketch this graph will go like that. It passed through 9, it go like that. So this is a situation whereby the function touches, we call this touches the x-axis. So what is the value of the b squared minus 4ac in this case? What do you think? Yes.
0.
Yeah, b squared minus 4ac. That is b squared minus 4, a is 1, c is 9. So I got 0. So that means if the value of b squared minus 4ac is 0, that means that quadratic equation will have only one solution. That quadratic function will have only one x-intercept. So can you tell me what is the range of this quadratic function? Can someone tell me what is the range? Yes. Y is a member or real number, or in this case, we say fx, and y is always greater than or equal to 0. Correct? The value of y is always 0 and above. Okay? So, can I give you a few minutes to determine this? See whether it got 0 at 1 x-intercept or not. You got 0 x-intercept or not? Okay, let's have a look. So what is the solution? X equal to -2 plus. So I'm 2 square root 2. Okay, I think I said the wrong question. Here should be a plus. This one a plus. This is a plus. That is a plus. That will be okay. 1/2. 2 or 1/2. Please faster use your scientific calculator. 2 correct. So now it's correct. 2. Those online, are you with me? You all disappeared already.
Yes.
Yeah. Okay. 2. So because so this is also because I put a plus there. So how am I going to create? I put everything negative. I should put it like that because I'm trying to get the other graph. Do you get me? I'm trying to get the other graph. I'm trying to get the other side, the crying curve. So actually I have to put this negative, put this positive, and put this negative. Am I right? Hello? You see? Time to retire. So if I put this negative, put this negative, and this one also go negative, and this one go positive, correct? Hello? Okay, you don't have to bother. Okay, so I will get the same answer, but because this is negative, A is -1, correct? So the graph will go like that. I just want to let you have a look at the different situation. So here is your 2, 0. Clear? So it also touches. And in this case, the b squared minus 4ac, the b is 4. Minus 4, your a is -1, your c is -4. This is your a. This is your B, and this is the C. Clear? Okay, so I also get 0. So second situation. So the third situation, I don't have to give you the example anymore. So I'm going to conclude the whole thing. I'm going to make a conclusion of the whole thing. Yeah. Can or not? Yes. Any issue? Any issue? Yes. The purpose of this. So that's why I call this a determinant. The value for this expression will help you, and it only can be used in a quadratic equation, not any others. Okay. So I'm going to make a conclusion. So this is what you have to take away for today. For any given quadratic functions, y equal to ax squared plus bx plus c. Okay. For any given quadratic function, y equal to ax squared plus bx plus c, to determine the number of x-intercept, we have to find the value of b squared minus 4ac. Okay, if I say the number of x-intercept, it also can mean number of solution for ax squared plus bx plus c equal to 0. And you have to know that solution must be real number. Can the solution be not real? So you won't solve the problem, am I right? So these are the few things that you have to take away. So to determine the number of x-intercept or number of solution for that, okay, we have to find the value of b squared minus 4ac. So b squared, if, so we have three situations. If b squared minus 4ac is less than 0, what does it imply? No real solution. Correct? So means 0 what? X-intercept. Are you clear? So this is a very important expression for a quadratic function. So second situation, if b squared minus 4ac is equal to 0, actually when I say solution, I don't have to say real. I just say no solution. Solution must be real, okay? No real root. We say no real root, but we don't say no real solution. No real root. Okay, if b squared minus 4ac equal to 0, what is the implication? real, and equal root. Okay, you don't have to know the meaning of the root. The most important thing, you have to know how many solution? One solution. How many x-intercept? One x-intercept. So the graph touches the x-axis. Correct? That is how I interpret. You see or not? My mind. I will go back to the graph. Yeah? Okay, what else? The last one. If b squared minus 4ac is greater than 0, we have two solutions. Maximum number of solutions, correct? Two solutions. That means two x-intercept. It means the graph cut the x-axis. Do you know the difference between cut and touch? That's how you go. Cut means like that. This is called cut. You see? So you got two x-intercept, two solutions. So this is the takeaway you must have for today's lesson. Other than that, you cannot understand, you don't know how to do, and you must know how to use your calculator to find the solution. You get me? Sketch graph, that one, never mind. We have graphic calculator, later we do it. I purposely sketch the graph is just to let you have the visual of it. So don't stress yourself up. All right? So this can only be used on what? Quadratic equation or quadratic function. Other than that, can you use it? No. Okay, afterward, during